There, it's Miss Flynn. Today we are going to spend some time with application problems and utilizing our graphing calculator. So I'm going to show you some ways that we can find some of these key concepts on our calculator, and then we'll take like just a mini quiz on it in about a week or so. So let's go ahead and get started. So let's everyone turn on the graphing calculator, and here's the on button, but we know how to clear our calculators because I ask you to do this every time after a test. So we do second plus 712. And this is going to give us all the same screen. So I'm going to hit clear. We all have the blank screen. If we hit graph, we all have the same graph. Y equals, everything's cleared out. So we're kind of just at a fresh start here. So let's go ahead and decide on a quadratic function to graph together, and that way we're all graphing the same thing. I'm just going to pick one. I'm going to pick y equals negative 2.3 x minus 4 squared plus 3.2. There's a lot of things that we don't know about this quadratic function, but we're going to just try to find our vertex and axis of symmetry. So everyone go over to y equals. We're going to type in negative, and you have to use this symbol, not your subtraction symbol, 2.3 parenthesis x minus 4 end parenthesis squared plus 3.2. So it's important that you're actually pressing pause and trying to work ahead and not just passively watching me, but actually working along and doing some of these together. So let's hit graph and see what we have. We have a quadratic function. It's concave down, opening down. And the first thing I'm going to show you how to find is our vertex. So there's going to be two possibilities with a graph. Our first possibility is when we have something that's concave down. So I'm just going to write concave down, because when we have concave down, we're going to be looking for this vertex right here, which is actually a maximum. Now our calculator will calculate our maximum. So what we want to do is we hit second trace, so second to calc. So let's go ahead and write down our keystrokes. Second trace, then we hit maximum, which is number 4, and we'll come to this screen. So I'm just gonna hit the number 4. It says left bound. So what I want you guys to do is to move your cursor until you get to where you think the maximum about is. Now on left bound, so let's write on here, move cursor to vertex. And then when it's asking left bound with a question mark, you're going to move the arrow left 2 times. So I'm on my vertex, I go 1, 2, and I press enter. Now it's asking for my right bound. So I move back to where I think my vertex is. And for my right bound, I move the arrow key 1, 2 places to the right. So I move this direction 2 times and hit enter. And then on guess, you can hit enter again. So guess, we hit enter again. So I'm just going to highlight some of our keystrokes. We hit second, trace, 4. We move the cursor, so that was 1 keystroke, to the vertex. And then on the left bound, we hit the left arrow over 2 times and pressed enter. Then when it asked us for right bound, the right arrow key over 2 times and hit enter. And then when it says guess, you hit enter again. And then voila, there's your vertex, 4, 3.2. 3.2, which you guys could have done without graphing. I know this, but we'll get into more complicated equations. Let's just go ahead and change one thing and find out what happens if we have a concave up. So what we can do for this is we can just erase this negative, and then we'll have a concave up. So let's go back to y equals. And I'm flashing right now on my negative. I can just hit delete there and then graph. I'm going to put this all in red. Maybe you saved a little bit of space, or you can squeeze it in somewhere. I'm just going to kind of squeeze it in right here. So when we have concave up, we now are going to have a minimum value. So we're going to ask the calculator to calculate a minimum. So we go back to second trace. So just like before, second trace. Now we're going to hit number, you guessed it, 3 for our minimum. So we hit 3. So before we answer that question to left bound and right bound, just like before, we're going to move until our cursor looks like it's at the vertex. So we'll write move cursor to vertex. And then now it's asking us the left bound. Remember, we hit the arrow left 1, 2 places. So I'll draw that 2 times, and then we hit enter again. Then we go back over to our vertex. Don't forget this step. And it's asking us now right bound. We'll move over right 2 times. So now we're going to move to the right 2 times. We hit enter again. And then our guess, you just hit enter for guess. And we have a minimum at 4, 3.2. Same values, of course, we knew that already. So again, I'll just go through it for concave up minimum. Keystrokes is second trace, number 3. We move the cursor to the vertex. For left bound, we hit the left arrow key 2 times and press enter. Then on the right bound, we move back to the vertex 2 times again and then press enter, and then guess we hit enter. For the axis of symmetry, we know the axis of symmetry is always the x coordinate of our vertex. So for this, we will want to find our maximum or minimum because it's always the x coordinate of our vertex. So for example, if it was concave up, it would be x equals 4. If it was concave down, it would be x equals 4. So we can go through that whole process again of finding our x coordinate of the vertex by just following these steps here. And then we write our final equation for axis of symmetry is x equals whatever that coordinate is.